Okay, here we are on a Friday evening after an 8th grade science lab on balancing equations, doing M&M balancing equations. And some of you are all having a little bit of a difficult time. So I went out to the store and I bought more M&Ms and I'm trying to make this video so you'll be able to see this as best as possible. Now, the first thing I want to do is read the sheets with you, and it says M&M Balancing Equations Lab. Number 1, use the M&Ms to model atoms. So we're making each one of these M&Ms stand for an atom. Okay? Set up the reactants using the correct number of M&Ms. So we remember on our chemical equations that the reactants are the left-hand side of the equation, the things that you put together, and it says move the same number of M&Ms to the product side. So here is the chemical equation. I'm going to move this up for a second. And here you have the two reactants, hydrogen, a molecule of hydrogen, two hydrogen atoms together, and a molecule of oxygen, two oxygen atoms together. And then as you put the reactants to the product and it yields the product, a reactant plus a reactant yields a product by some chemical reaction, some kind of change, you're going to move the M&Ms, you're going to see them on this side. So it says move the same number of M&Ms to the product side. As they become more difficult, you may need to set up the products first and work backwards. Set up the molecules and fill in the coefficients. So you remember that the coefficients are the numbers in front, where is it over here? In front of the molecule. The numbers of molecules that each one of these is. So over here on the sheet that you got, the second sheet, the number of water molecules. Because by now, you probably all remember that H2O is just the chemical name for water. That's a water molecule. So the number, if I had 1 in front of there, that would be 1 water molecule. If I put a 2 in front of there, that would be 2 water molecules. Okay. So going back to here, it says, set up the molecules and fill in the coefficients. Draw and color the equations that represent the reactions. Okay. So we're going to be doing this a little bit differently because after I did this all following the directions, I found out I had to do it a little bit differently to help me understand it the best. So sometimes we do something and we figure out an even better way to do it. So I want to do it the way so that you understand it the best. Remember that you cannot change the subscripts. So what is a subscript again? If you remember, we just said that the number in front of the molecules is the coefficient, and we can change that, and that's why we left it blank, so you can write it in pencil, and if you make a mistake, you can erase it, and you can change it. But the coefficient, not the coefficient, the subscript, that's written in ink on the paper, and you cannot change it. It's just you can never change your subscripts the way that the molecules are put together. And you'll be learning more about that later. So you can only change the coefficients. When you change the coefficient, you add more of the entire molecule. So here we have H2O, we have the water molecule, and that becomes 2 H2Os. So we'd have now not just 1 water molecule, but how many water molecules? Look at that coefficient. Yes, 2 water molecules. Okay, so we have a data table. And some of you might have gotten a little bit confused yesterday, or today actually, Friday, because the data table on the one side of the sheet has different colors for the atoms than on the other side. But remember, it really doesn't matter what color your M&Ms are. This is just a model to help you understand. So I already counted out the number of atoms. So for the atom O, and what does O stand for? Right, oxygen. And we made that blue, and I counted out 12 blue M&Ms. And H is hydrogen. I counted out 8 hydrogens, 8 M&Ms, brown M&Ms. Na is sodium, and I counted out 4 orange sodiums, 4 orange M&Ms, because the M&Ms are our model for the sodium atoms. And the Cl stands for chlorine, and I counted out 4 yellow M&Ms to stand for the 4, for any 4. These are just the data to help us build our model. And the K for potassium, I counted out 4 red M&Ms to represent 4 potassium atoms. And for calcium, I counted out 6 M&Ms for green M&Ms. Oh no, not 6, I'm sorry, 2 green M&Ms to represent calcium atoms. So I'm going to move this out of the way so you can see it up here just a little bit. And I might have to do this in 2s if the battery runs out of my iPad. I'm just doing the best I can. Okay, so understanding balanced chemical equations. When chemicals react, atoms are conserved. This means there must be the same number of each atom on each side of the arrow. So here's reaction number 1. And we've already talked about this before. Hydrogen, and remember we said they hang out in 2s. They're diatomic, 2 atoms together making 1 molecule of hydrogen, because if there is no coefficient, we understand it to be 1. And oxygen also hangs out in 2s. It's a diatomic, 2 atoms together of oxygen in 1 oxygen molecule. So we're going to take what color for the hydrogen? H is brown. So we're going to take 2 brown M&Ms and put them together, because once again, hydrogen hangs out, or hydrogen is a diatomic molecule. It stays in 2s. And now oxygen was blue, so we're going to take 1, 2 oxygens, and again, we're going to put them together because oxygen hangs out, or is usually found in the atmosphere as a diatomic molecule of 2 atoms, 1, 2, the subscript is 2, of oxygen. Okay, now when we put these together, it is going to form 1 molecule, because again, the coefficient right now is only 1 molecule of H2O. And we remember already that H2O is water. So I'm going to take 1 molecule of hydrogen, brown, and another molecule of hydrogen, another brown, 2, and 1 molecule of oxygen, and oxygen is blue. And it usually forms together with the hydrogen is bonding with the oxygen on the side, but don't worry about that. You'll learn about that later. Okay, now let's look. Is this balanced? How many H candies, hydrogen candies, are on the left side? This is the left, and this is the right. And you can remember that in case you get stuck, that L, when your hand goes out like that, that's your left hand. And your other hand is your right hand. Okay, so how many H candies are on the left side? Count them up, the brown ones. 1, 2. Oops, let's put them back together, because we remember hydrogen hangs out in 2s. It's diatomic. So how many H candies on the left? 2. Let's write the number 2. What about on the right? 2. Okay, that's balanced. Now, how many oxygen are on the left? Oxygen is blue. 1, 2 on the left. And what about on the right? Uh-oh, only 1. Is it balanced? No. So is the equation currently balanced? No. Now, what do we have to do? Remember, our equations have to be balanced. When these molecules, the hydrogen molecules and the oxygen molecules, react together, when they combine in a chemical reaction, we remember from the law of conservation of mass, or law of conservation of matter, matter is neither created nor destroyed. We didn't destroy this atom of oxygen. It was still there. So what could we do so we still get water? Well, we can balance our equation. So a way to balance it is to just count up the number of atoms. So hydrogen. On the reactant side, oops, I've got to erase it. I didn't write it where I could do it. Okay, so we have the reactant side and we have the product side. So I'm going to put R for reactant and P for product. And I'm going to put H because we have hydrogens. Oops, let's put those together again. Together. And we have oxygen. So on the reactant side, we have 1, 2. On the product side, we have 1, 2. Okay, balanced. On the oxygen, on the reactant side, we have 2. And on the product side, we have 1. So we're going to have to end up with another. You can start either from go from the product to the from the reactant to the product, or the other way around. So if I've got oxygen usually occurring in 2s, I have to have 2 oxygens over here. Let's put another oxygen there. So now I've got 2. I changed it to 2, but what about the other hydrogen, the other part of the water molecule? It's not there. So what do I have to do to the hydrogens? I've got to put more hydrogens there. So here I can put 2 more hydrogens. So 1, 2, 3, 4. And now I have to put 1, 2, 3, 4 over here. So I changed the number of hydrogens to 2, and now I have 2 hydrogens over 1, 2, 3, 4. 2 times 2 equals 4, and 1, 2, 1, 2, 1, 2, 3, 4. Is it balanced? Yes. So I had to multiply my hydrogens by 2. I had to 2 molecules of hydrogen, and I had to take another one of the oxygens and put it over there. So I could have 2, because we could remember I couldn't destroy my oxygen I had to just rearrange it into another molecule of water. But I had to get more hydrogens to make that other one. Do you all understand that, or do you need me to do it again? Okay, if you need me to do it again, just email me at barbara.isasi@dpsnc.net, and I'll do it again. I'll try to make it a little better understandable. Okay, so now it's balanced. And now we can go to the next page. And again, remember, it might have been a little bit confusing because there were different colors, but it really doesn't matter if the oxygens are blue or the oxygens are green. It's just a model to help you understand. Okay, so I'm going to move these out of the way so you can see them. Okay, and I just counted up the green, the yellows, the sodiums, the chlorines, the potassiums, and the calciums. Okay, so reaction number 2, calcium chloride. And I put, sodium chloride, oops, Na, sodium. And I can move these out so you can see these words better. And I tried to write it in colored pencil, the color that it is. So sodium is orange, so I wrote it in orange. And so you have 1 sodium and 1 chlorine. So you're going to take 1 sodium and 1 chlorine, and chlorine is blue. And again, don't get confused by the other one. It just really doesn't matter what color you pick. And there it is as a molecule together. And then this one, 1 calcium oxide. And I go brown for the calcium. No, that's red. Brown for the calcium and green for the oxygen. Calcium oxide becomes sodium oxide. So now how many, look at that subscript, how many atoms of sodium do we have? 2. So I'm going to go to my sodium, orange, and I'm going to take 1, 2 atoms. Uh-oh, I can already see that it's not balanced. I've got 1 sodium over there, and I've got 2 sodiums over there. But in this molecule, I'm not done with this molecule of sodium oxide. I've got to put 1 oxygen. So I go to my green, and I put 1 green, one oxygen. So the greens are balanced, the oxygens are balanced, but we can already see that our sodiums aren't balanced. So we're going to have to do something to put more sodiums over here, because there's 2 of them over there. But let's keep going first, and then we'll see what more we have to do. So CaCl2, calcium chloride. So I go to 1 calcium, calcium's brown, I take 1 calcium, and Cl, chlorine, is blue in this model. So I take 2 blues, 2 chlorines, excuse me, because the subscript for the chloride, the chlorine, is 2. So chloride, it makes it 2 atoms. And once again, it's not just separate, it's all 1 molecule together. Okay, well, I can see a little bit. So we can count them out. And we've got sodium, so let's put R for the reactant and P for the product. And we've got sodium, Na. We've got chlorine, Cl. We've got calcium, Ca. And we've got oxygen, O. Okay, Now on our reactant side, sodiums. I've got one sodium over here for the reactant, but I've got 2 for the product. We know that's not balanced yet. We'll get there. Okay, chlorine. We've got 1 chlorine in the reactant, but we've got 2, whoops, my molecule came apart, 2 on the product. We know we're going to have to do something to give me more sodiums and more chlorines. And the calcium, oh, 1 second, chlorine, I did calcium, 1 second, I have to back that up. I think I got confused. Where is it? Paper's over here. Okay, go back to the chlorine. Chlorine is blue over here, so 1 chlorine over here on the reactant, that's right, and 2 on the product. Okay, that's right. Now the calcium. Calcium is brown, 1 calcium in the reactant, and 1 calcium in the product. So that's okay. So far we've got sodium, it's not balanced, and chlorine, it's not balanced. Let's look at the oxygen. 1 oxygen for the reactant, and 1 oxygen for the product. So that's balanced. So all we have to do is change the Na, the sodium, and the Cl, the chlorine. Oh, look, sodium and chlorine go together right here, just right together. We don't have to do too much, except we have 1 on this side and 2 on this side. So we've got to make this one into 2 to balance. So let's just take another molecule. There's my sodium. Oh, separate molecules. Sodium, and what's chlorine? Blue, chlorine. So now I've got 2 molecules of sodium chlorine, and I have to put a 2, the coefficient 2. I just changed it from 1 to 2, 1 to 2, and now is it balanced? 2 and 2? Yes. Now it's balanced. So all I had to do was, put that molecule back together. Okay. So I didn't lose, I couldn't take this, I couldn't just create this. I had to just rearrange my atoms. Okay. So when we have the reaction of sodium chloride plus calcium oxide producing or yielding sodium oxide and calcium chloride, we have to make sure we have 2 molecules of sodium chloride, because we remember that matter is neither created nor destroyed. It's only rearranged into new chemical compounds. And there are our new chemical compounds. They don't look like these chemical compounds, but the atoms do look the same. They're just in different arrangements. Okay? And you want to write the balanced equation, or I just wrote it up here. I just changed the coefficient. So you could write the balanced equation: 2 NaCl's, 2 sodium chlorides, plus, and you understand it to be 1, calcium oxide yields or produces 1 sodium oxide, Na2O, plus 1 calcium chloride. And I'm running out of room a little bit. Calcium chloride with the 2. Okay, reaction 3. You getting the hang of this now? Reaction 3. Potassium chlorate, and again, I tried to use the red because red was for potassium, chlor for the chlorine, and 8 for the oxygen. Potassium chlorate yields potassium chloride. Look, it only has 1 chlorine and no oxygens, plus O2, oxygen. And remember that, again, that's diatomic, 2 atoms. Di means 2, diatomic oxygen. Okay, let's do this again. K is potassium. Yes, potassium's in bananas. Get a red. Red for potassium. 1 potassium. How many chlorines? Look at the Cl up at the top. Chlorine is blue. Get 1 blue. 1, 2, 3, 4. Didn't make me add any more blues. I'm going to go take a blue from this side, from the previous paper. Boy. Okay. 1 blue, 1 chlorine. And how many oxygens? Oh, 3. Let's take 3 green M&Ms to model our 3 oxygen atoms in this molecule. And that's all 1 molecule. And again, it's just a model. Don't worry about how it looks so far. Just understand that we're just doing it to represent potassium chlorate. Okay, now potassium chloride. Okay, so it decomposes, potassium chlorate decomposes or breaks down into potassium chloride and oxygen, or it yields. So when we break this down, it yields potassium chloride. So there's the potassium. Let's go get, oh, I need another potassium. Another red potassium from this side. And a chlorine from over here, a blue chlorine. Getting another blue one from the other page. Boy, okay. Chlorine, there we go. So I've got brown, brown, blue, blue. Green, I've got oxygen. Uh-oh. It's only 2 oxygens together. Again, is this balanced? Can you do this on your own? Let's see if you can. Try and see. We'll pause this and let you do it. Okay. Did you come up? Did you first write out your R for the reactant side on the left and the P for the product side, and then all of your atoms? Your K, your potassium, your Cl, your chlorine, your O, your oxygen, and write out the number that you see. K, there's 1 on the reactant side, and there's 1 on the product side. Chlorine. There's 1 on the reactant side, and there's 1 on the product side. Oxygen. You've got 3 atoms there, and you only have 2 there. What do you need to do? Oh my goodness. Remember, you can't create it. You can only rearrange it. How can you get this to balance? 3 and 2. Well, from math, you learned about least common denominators. So what can you do for least common denominators? You have 2 and 3. What's your least common denominator of 2 plus 3? If you said 6, you are right. So we have to have 6 on each side. So, oh boy, I've got to go into the M&M bag. I don't even have enough green M&Ms from the other one. Okay, so I've got to have 6. 1, 2, 3, 4, 5, 6. But this oxygen is not going to hang out by itself. We said it's molecules of potassium and chlorate. So I've got to put the rest of the potassium chlorate in there. So I've got to get a brown and a blue. So the brown and the blue, so I had to make that into 2 molecules of potassium chlorate. Okay, well, now I've got a brown and a blue on this side. Got to have the brown, it's not balanced. I've got 1 brown and 1 blue, 1 brown and 1 blue, but only 1 brown and 1 blue. It's got to balance over there. What is going to happen with these two? They're going to form another molecule of potassium chloride. So now I've got 1, 2, 1, 2. So I had this changed into 6. This changed into 6. So I multiplied 2 times 3 for the oxygens, and that gave me 6 oxygens. And here, if I'm going to get 6 over here, I'm going to have to end up with 6 over there. And we remember that oxygens hang out in 2s. They are usually found as diatomic atoms, diatomic molecules. Diatomic molecules, 2 molecules, 1, 2, 3, 4, 5, 6. So that's going to be, remember the subscript never changes, but the coefficient can. 3 times 2 is 6. It's balanced. 2 molecules of potassium chloride, 2 molecules of potassium chlorate, 2, have to separate them, 2 separate molecules. We don't have a super molecule. We have 2 molecules of potassium chloride. And now the blues are balanced, 1, 2, 1, 2. The browns are balanced, 1, 2, 1, 2, and the 3. And remember, the blues, you go to the chart. What blue is the chlorine, and the brown is the potassium. No, brown is the calcium. 1 second. It's not supposed to be brown. It's supposed to be red. That's supposed to be red. Oh, red. That's not supposed to be brown. That's supposed to be red. I'm sorry. I hope I didn't confuse you. Okay. Reds and reds. Last one. So you could write that equation, 2K potassium chlorine and oxygen 3. 2, now we have 1 molecule, 2 molecules, and that does 3 oxygens. Okay, so you can write that all out. 2KClO3 plus, yields, produces, decomposes into 2 potassium and chlorine plus 3 oxygen, 2 oxygen molecules. Last one, KOH. Boy, this is getting long. KOH. So again, potassium is red. Got to go over here for some reds. 1 potassium, 1 oxygen, green. 1 hydrogen, yellow. Plus a sodium. Sodium's orange. Running over here for orange. Yields a sodium, an oxygen, and a hydrogen. A sodium a green oxygen back into the bag. No, I've got a green up there. Oxygen and a hydrogen. So potassium hydrochloride and sodium yields sodium hydroxide and potassium. And there is a potassium, a red one, over here for more reds. Okay. Look at it. See if it's balanced. Okay. I've got a brown, I've got a brown. I've got a green, I've got a green. I've got a yellow, I've got a yellow, and I've got an orange and an orange. Is that balanced? Double check it. Looks balanced to me. I'm going to check it again. Let's do our little chart. Reactants, products, potassium, oxygen, hydrogen. Reactant side, potassium. I've got 1. I've got product 1. Oxygen. I've got oxygen is green. I've got 1. Product side, I've got 1. And sodium, I've got 1 on the, oh, that's, wait a minute. I got left out sodium. Got to put this down a minute. Sodium, what color is sodium? Sodium is orange. I have 1 sodium and another sodium, so left out the sodium. Na. 1 and 1. And now hydrogen. Hydrogen. Hydrogen was yellow, 1 and 1. I think I've got, yep, 1 and 1. So look what, it's already balanced. Don't have to do anything to it. That's the equation. Good job. Okay, we'll do the other page another time. This is taking a long time. I hope this has helped you. You can do the other page on your own. We'll look at this. Here you go.